Hello everyone. Today I will discuss about the basic concept of pushdown automata and Turing machine. So before discussing about pushdown automata and Turing machine, we have to know that what are the shortcomings in deterministic finite automata or non-deterministic finite automata. In deterministic and non-deterministic finite automata, they cannot accept the strings like a to the power n and b to the power n, where the number of a and number of b's are equals in nature, or the strings like a to the power n, b to the power n and c to the power n, where the number of a, b and c all are equals in nature. So these types of string finite automata can't accept. Why? Because no memory is associated in finite automata. That is why it cannot memorize that how many input symbol it already accessed or it already scanned. That is the first shortcoming or disadvantage of finite automata. That is why by using pumping lemma we can prove that these types of language, that is a to the power n, b to the power n, or a to the power n, b to the power n, or c to the power n, these types of strings cannot be accepted by finite automata or non-deterministic finite automata. That is why we need these types of automata, which is known as the pushdown automata and Turing machine. Next slide. Next slide. So the basic concept of pushdown automata is it is always finite in nature and one stack is associated with this finite automata. So it is a combination of stack and finite automata. Now the question is why we need stack? To memorize how many input symbol we have already accessed. So it is one type of auxiliary memory which is associated with pushdown automata. So pushdown automata is nothing but the combination of finite automata and stack. Now the question may come that why we need these types of special data structure which is known as the stack. Because here the addition and deletion of any input symbol is very much easy by using stack. That is why we accept stack as a data structure in pushdown automata. So this is our first point, that pushdown automata is nothing but it is combination of finite automata and stack. And the second point says yes, it has an auxiliary storage to accept a context-free language. So this is another point we have to memorize, that the language which is accepted by pushdown automata is context-free language. So context-free grammar can generate context-free language, and this context-free language can be accepted by pushdown automata. So pushdown automata mainly has three things: one input tape, one finite control and a stack. So what is input tape? It is nothing but a tape which can consist a input string or combination of input symbol. Finite control is used to just accept an input symbol and go to from current state to the next state. So here the number of state is finite in nature, and finite control accept an input symbol and goes to from current state to the next state. And obviously a stack which is associated with pushdown automata, and it will store all the scanned inputted symbol. Now the fourth point says that pushdown automata will be deterministic and also a non-deterministic in nature. So point to be noted that always non-deterministic pushdown automata, it is much more powerful than deterministic pushdown automata. And the last point says that the language which is accepted by pushdown automata is known as the context-free language. Now this is a mathematical definition of pushdown automata. So it says that pushdown automata is combination of 6 quantuples. You know what is the meaning of Q? It is non-finite number of state, non-empty finite number of state. Summation is a non-empty finite of input symbol. This is a transition function, small delta. Small s is the initial state. Capital F is a final state. And it is a new term which is known as the tau, which is a set of pushdown symbol. Means after scanning a particular symbol, we have to store into a stack. So the symbol which is already stored into the stack, which is known as a tau, this special notation. Now we will discuss about the working principle of pushdown automata, how pushdown automata will work. So these are the 3 special movement by pushdown automata. So pushdown automata can accept an input symbol. After accepting, it will store the input symbol into a stack. Now what will happen after accepting an input symbol? 3 things will happen. It will replace the top of the stack by new scanned symbol. Again I am repeating, it can replace the top of the stack by newly scanned symbol. Means it is one type of replacing the stack. This is number 1. Number 2 is it can delete the inputted symbol from the top of the stack. Number 3 is it can add the inputted symbol into the top of the stack. And the last one, which is it can do nothing. So one by one I will explain each and every movement. So first movement says that, see, this is a transition function. Within first bracket, here it is Q. Q means the present state, A is the scanned symbol, and Z is, which is the notation, which is one type of symbol which always point out the top of the stack. So here Z is one type of notation which will point out the top of the stack. So it is our present state. After accepting an input symbol A, it will goes to another state, the new state, which is denoted by small p, and Y is the symbol which will replace a top of the stack. So top of the stack is Z, Z will be replaced by Y. So this is the meaning of this transition. So after execution of this transition, the top of the stack will be replaced by the symbol Y. Now how can we push any symbol into the stack? Here our current state is Q, top of the stack symbol is the scanned symbol is A, and there is no symbol at the top of the stack. That is why it is denoted by null sign. Now after execution, the present state will goes to a new state which is denoted by small p, and we are going to insert a current symbol into the top of the stack, that is A. Now how can we pop any symbol from a top of the stack? Here our present state is Q, top of the stack is top of the stack is Z, and inputted symbol is A. So after accepting an input symbol, we just remove the top of the stack. That is why P comma null means P is the current state, and now the top of the stack is empty. Empty is denoted by this null sign. And the last movement is very much important. PDA can do nothing. How? See, this is our current state, this is inputted symbol. After accepting a inputted symbol A, it will do nothing. Means Z is again remains Z. Z is notation of top of the stack, so Z will remains Z again. So these are the special movement of PDA. Now we will see few example on pushdown automata. So this is our first example. The example says that we have to design a pushdown automata that can accept a language where W, A, comma B whole star, where W is a string which has the equal number of A and equal number of B. So how W look like? It can equal number of A and equal number of B. So how can we design our pushdown automata? We have to design our pushdown automata in such a way that at first it can accept a number of A's. When it will get B after accepting A, then it will remove A for corresponding B. See, these are the transaction. These are the transaction performed by pushdown automata. So at first in stack there is no symbol. So at first the stack is empty. So Q0 is our initial state, and at first the stack is empty and the input tape is also empty. That is why there is null comma null. Now we are going to insert a special symbol which is known as the Z. So what is the purpose of Z? It is always point out the top of the stack. If a stack contains only Z, what is the meaning of that? Now the tag is empty. That is the meaning of that. So Z is used to always point out the top of the stack. Now we are going to insert a number of A into the stack. So our current state is Q0. Now we are going to scan input symbol A, and what will be the top of the stack? That is Z. So after accepting A, it will store the current inputted symbol into a top of the stacks. So this is the movement AZ. What is the meaning of that? We are going to place input symbol A just upper portion of Z. Now we are accepting again A. So here Q0 is the present state, inputted symbol is A, and what is the top of the stack? What is the top symbol of the stack? That is also A. Now we are going to push A just upper portion of A. That is why it is A. Now what will happen? The strings will start with B. Now we are going to insert input symbol B, top of the stack is B, so we can easily place the B after B, Q0 B comma B. Now this movement is very much important. This movement says that what will happen, we are going to insert B after A. So here the input symbol B and the top of the stack is A. Now what will happen? We just delete A corresponding to B. That is why it will null. So if we get A after B, then we have to remove these two symbols. Now this is one possibility, that is our current symbol is A and the top of the stack is B. These things also happen. So if these things will happen, then again we have to remove corresponding B for A. That is why it is null. And at the last, there is no symbol into the stack, just Z over there, means now the stack is empty. So we can now end our execution. So that is why Q0 turns into QF, QF nothing but the final state, and Z will remain Z again. So this is the overall solution of this example, that is string has equal number of A and equal number of B. So this is the transition diagram. So here our inputted symbol is 3 times A, 3 times B. So at first we are starting from here, this is our initial state, and at first the stack is empty. So we are going to input a symbol Z over there. Now we are going to insert A. So what will happen? The top of the stack is Z, our inputted symbol is A. So this transaction, top of the stack is inputted symbol is A and the top of the stack is Z. So we can easily add A over Z. Now we are going to insert another A. So our inputted symbol is A and the top of the stack is also A. Inputted symbol is A and the top of the stack is also A. So we can easily add A over A. Now what will happen for first times B? Our inputted symbol is B and the top of the stack is A. So if this condition will happen, then we have to remove these two symbols, B and A also. So this is the transaction. If our inputted symbol is B and the top of the stack is A, then we have to delete both of them. So like this, we have to carry these things, and at last the stacks will empty, only the symbol Z will left. So if only the symbol Z will left and the input tape will empty, so this is the empty sign, then Q0 goes to QF, that is final state, after remaining the Z into the stacks. This is another problem. Example 2 says design a pushdown automata for the language a to the power n, b to the power n, where n is always greater than 0. So we have seen in deterministic finite automata that deterministic finite automata cannot accept these types of strings. By using pumping lemma we can prove that. But pushdown automata can accept these types of string. How? So a to the power n, b to the power n means always the number of A and number of B are equals in nature. So first thing is that we have to input Z, which is the notation of the stacks, whether the stacks is empty or not. So first of all we have to input this Z symbol into the stacks. So this movement we have to do at first. Input tape is empty and the top of the stack is also empty, so we are going to add Z symbol into the stacks. Now we are going to insert A. So what will happen? Inputted symbol is A and the top of the stack is Z, so we can easily add A and Z. Like this we can also add A after A by using this transaction. Now what will happen if we want to B after A? What will happen? Again we have to delete them. Every A for corresponding B we have to delete them. So this transaction will do this thing. If our inputted symbol is B and the current symbol is A, then we can't delete, we have to delete this. So the last transaction is null. So after that the stacks will empty, only Z symbol will left over there. So we have to go from current state to the next state and Z will remains. So if we see the pictorial representation. So that is the solution. Number of A and number of B is equal and value of n equals to 2, that is why 2 times A and 2 times B. Now what will happen? First of all, we are going to add Z symbol into the stacks, which is the notation whether the stack is empty or not. Now we have to add A after Z. So this transaction will happen. Inputted symbol is A and current symbol is Z. So we can easily add A over Z. Now our inputted symbol is A and the top of the stacks is A. So this transaction will happen. A comma A, it will comes AA. Now what will happen? We are going to add B over A. So if we add B over A, then we have to delete corresponding B for this A. So this transaction will happen. Q0 will goes to Q1 and the resultant string is null. So by this we have to remove all these symbols from the stacks and only Z is left over there. So after Z, Q1 will goes to QF and only Z will remains over there. So by this way we can accept this string A to the power n, B to the power n. Now the third problem says that design a pushdown automata for this language. WCWR means W is a string and WR is reverse of the string, and C is the notation by which we can point it out that where is the end of the string. So these types of strings we have to accept by using pushdown automata. So these are the solution, these are the possible solution or possible transaction. So first of all, we have to again input a notation Z into the empty stacks. So first of all we have to insert a Z. So this transaction is not written over there, but we have to show it. After inputting a Z, now we have to input our string. Say the string is starts with A. So we have to apply this transaction. The top of the stacks is Z and input symbol is A. So we can easily add A over Z. Now again we have to add another A. So inputted symbol is A, top of the stacks is A, so we can easily add them. Now what will happen? The string is like B, B, B. So our inputted symbol is B and the top of the stacks is also B. So we can easily add B over B. So this transaction we can apply. So by this way we can add the combination of A and B into the stacks. Now C will comes into the picture. What is the meaning of C? C is the endpoint of my inputted string. Now we have to reverse our string. So C is the notation, one type of notation by which we can identify what is the endpoint my inputted string. So here our inputted symbol is C and this transaction. Inputted symbol is C and the previously added symbol into the stacks, which is A. So what can we do? We have to skip our transaction, means no useful modification is over there, no modification is over there. We just left C and go to the another new state from Q0 to Q1. So now our present state is Q. Now what will happen if we get B and our previously added inputted symbol is A? What is the meaning of that? We are getting B and our previously added inputted symbol is B. So every B, the corresponding B we have to remove. So this is the remove sign. Now this condition is also possible. We are going to input A and previously added symbol is A. Now we have to remove both of them. So by this way we can empty the total stacks, only Z is left over there. So at last we have to change our present state. So our present state is Q, then from Q1 we go to QF and only Z is left into the stacks. So these are the possible transaction we have to apply. So if we see the pictorial representation, then the thing will be very clear to us. So this is the pictorial representation of this solution. So our inputted symbol is like this: ABB, CBBA. So this is our inputted string and this is the reverse of this particular string. See, at first our stacks is empty and we are going to add A. So this will be our possible transaction. So stacks is empty means only Z is left over there. So A is inputted symbol and Z is the top of the stack. We can easily A over Z. Now we are going to add B over A. So this transaction we have to apply. Inputted symbol is, this one. Inputted symbol is B and the top of the stacks is A. So we can easily add B over A. Now again another B we have to add. So inputted symbol is B and previously added symbol is B. So we can easily add B over B. Now what will happen if we are going to input C symbol? So when we are going to input C symbol, then it just skip the present state. So our present state is Q. So it will go from Q0 to Q1 without modify anything. So A will remain same, B will remain same. Just it will change the state. So now our present state is Q1. Now we are going to take our input symbols B. So what will happen? Our input symbol is B and previous symbol is also B. Then we can remove B for this corresponding B. So this 2B will remove. Now again we are going to input this symbol, that is B, and our previous symbols is also B. So we have to remove B for this B. So this transaction we may apply. Now what will happen? Our input symbol is A. So for this A, the previously added symbol is A. So this 2A we have to remove. So this transaction we may apply. At last the stacks is empty, only Z is left over there. So we can change our state from Q1 to QF, and this is the end of our solution. So these are the procedure by which we can design our pushdown automata for corresponding language. Now next topic is Turing machine. So there is few disadvantage of pushdown automata. The disadvantage is it cannot accept the strings like a to the power n, b to the power n, c to the power n. So by using pumping lemma we can prove these things. So to overcome these types of disadvantage or shortcoming in pushdown automata, we need such a powerful machine which can accept all type of strings in a universe. So Turing machine do these types of solution. Turing machine is such type of machine, it can accept all type of strings in a universe, all types of functions in a universe. That is why it is a very much powerful machine. So scientist Alan Turing and Church has first proposed these types of machine which can accept all type of strings in a universe. So in the year of 1932, so they proposed these types of machine. So this is a quotation of Mr. Church. A function is computable if it can be computed by Turing machine. So if function does not computable, we can say that it does not accepted by Turing machine. So it has a highest power, Turing machine. So what type of language Turing machine can accept? It can basically accept the recursively enumerable language. Turing machine may be deterministic, may be non-deterministic in nature, and these things is very much important that Turing machine acts as an enumerator. It can list the elements of the set. So it can act as an enumerator. So these are the physical diagram of Turing machine. It has a tape and the finite control. So the tape has a special functionality. The functionality is that the tape is divided into number of cells and each and every cell can contain symbol. And this tape can contain blank symbol also. So this is a special features of Turing machine. Here the tape can contain the blank symbols also. And there is a read-write head. So in our previous machine, in Pushdown Automata, head can only read the symbol from left to right. But here it has read capability, also has a write capability. So it can read the symbol and after scan or after execution, it can also write into the input tape. So it is known as the read-write head. And this is a finite control system. What is the purpose of finite control system? After accepting an input symbol, it just changes the state. It will go from current state to the next state. So finite control has the number of state which is divided into three parts. It has initial state, it has halt state. So yes, there is another point. It has no final state. The state which is known as the halt state. So we can halt the Turing machine. And other intermediate states, if necessary, we have to add over there. So these are the special features of Turing machine. And here another point is this read-write head can move in left direction and also a right direction. But in previous machine, read head can only move from left to right. But here in this Turing machine, read-write head can move left direction and also a right direction. So if I want to draw a few difference between pushdown automata or finite automata with Turing machine, so these are the basic difference between them. In finite automata, the cell of the tape is only for read or scanned, but in Turing machine we can read the input symbol and also write onto the tape. So it has read and write capability. In pushdown automata or finite automata, the tape head always moves from left to right, but here the movement in both direction in Turing machine. In pushdown automata, it accepts regular and context-free language, but Turing machine can accept recursively enumerable language. So that is why pushdown automata has less power and Turing machine is much more powerful than pushdown automata or finite automata. So these are the basic difference between these two machines. So how can we define mathematically Turing machine? So these are the few quantuples, 1, 2, 3, total 6 quantuples. By using 6 quantuples, we can define Turing machine mathematically. We know that Q is the finite number of state, summation is the inputted symbol, delta is the transition function, Q0 is the initial state, and this symbol is known as the set of tape symbol. Means after performing the write operation, what are the symbol we are getting which is denoted by this tau, and this symbol including the blank symbols also. And H is the halt state. And this is a transition function. So see, every Q after accepting a inputted symbol, it will again goes to another state which is also in Q, and the movement will be left, right or neutral. So these are the some movement of Turing machine. So there are basically 4 movement which is performed by Turing machine. First of all, it can scan the input symbol. After scanning, it will write a particular symbol into the tape. After that, after performing the write operation, it can also add a specific symbol into the step. It can also remove a specific symbol from the steps, or it can perform nothing. Means the read-write head remains neutral in nature. So these are the special movement which is performed by the Turing machine. So see the first point which is written over there. The transition is look like this. Delta Q comma C equals to Q1 B comma R. What is the meaning of that? Q and Q1 is the finite number of state. So our present state is Q and our inputted symbol or the scanned symbol is C. Now, what is the purpose of control machine? Control machine scanned the input symbol C and it will write a symbol B over C. And after performing the write operation, what will be the direction of read-write head? The direction is right. So capital R means it will go in right direction after performing this write operation. So see, the Turing machine currently scan the symbol C, will enter a state Q1 and move towards right adjacent cell after replacing C with B. Now, this is a special operation, that is delta Q1 comma A equals to Q2 B comma L. What is the meaning of that? Our present state is Q1 and scanned symbol is A. So after performing the scan operation, it will write A with B and the movement of read-write head will be left. And the third point says that the read-write head will do nothing. Means this is a transaction delta Q1 comma X, Q2 Y comma M, means our inputted symbol is X. After accepting X, the Q1 state will goes to Q2 and X1 is replaced by Y symbol. X is replaced by Y symbol, but after performing the replacement operation, the read-write head will remains on same position. That is why it is written N, means neutral. So these are the basic operation which is performed by the Turing machine. So few things we have to remember. The first thing is that Turing machine has the highest power. It can accept all language in the universe. So basically it will accept a recursively enumerable language and a recursive language also. And it also accept a context sensitive language. So these are the special features of Turing machine. And here the read-write head will accept the input symbol, and after accepting it will also write over there input tape. So these are the basic operation which will perform by Turing machine. So now I will conclude my lecture. So today we will discuss about the basic concept of push-down automata and Turing machine. Thank you.